Volumes of prisms and cylinders. Good news is this is, I think, much, much simpler than surface areas. Volumes are really pretty simple, especially for these guys. They get a little tougher with the pyramids, but prisms and cylinders, no big deal. So we want to learn to use these volume postulates and then to calculate volumes of these cylinders and prisms. Okay, the volume of a solid is the number of cubic units contained in its interior. That's one thing that's, it's important for us to know. So we've switched up, if we were dealing with units here, instead of square units, like we would have for areas, square feet, square inches, now we've got cubic units, cubic feet, cubic inches, cubic meters, etc. The volume of a cube, we know, that's pretty simple. Volume of a cube is just the side length cubed, right? And maybe that's why we call it a cube, I don't know. But those words go together. Something that's important to also remember here, the volume congruence postulate tells us that if two polyhedra are congruent, then of course they have to have the same volume. That makes sense to us though, right? Because we know that congruent objects have the same, two things? Two objects. If two objects are congruent, size and shape. And isn't the size and the shape obviously going to correlate to the volume, right? So it just makes sense then that congruent polyhedra must have the same volumes. And then another real important one, volume addition postulate. The volume of a solid is the sum of the volumes of all its non-overlapping parts. And what we're getting at here, you might expect is, remember in 12.2 and or 12.3, I think it's 12.3, is where we ran into some really weird looking shapes where you had things like pyramids sitting on top of prisms, weird stuff like that, right? And we had to add up surface areas. And to do that, we had to kind of mix and match with our formulas a little bit. We do the same thing with volumes. But with volumes, it's easier. It's easier because we know that if we were to, for example, laugh at my limited drawing ability here, I'm sure, but if we were to add up the volume of something like this, if we were to add up the volume of this guy, it's a lot easier than adding up surface area because we could just divide this into two pieces. We could just divide this into the volume of the pyramid, the whole volume, plus the volume of that prism, the whole volume. We don't have to worry about things like when we calculated the surface areas, remember that there was actually only one base in the whole shape, right? And so that kind of messed up our formulas a little bit. We had to add up the lateral areas of both the pyramid and the prism, and only one base, and so things got changed. With with volumes, much easier. We add up the whole volume of the pyramid plus the whole volume of the prism, and the sum is going to be, the answer, right? So for many reasons, this ends up being an easier section than the last one. So just a little picture to illustrate, if we're finding that the volume of a rectangular prism, well, that's just how many unit cubes we can stick into the fish tank or whatever it might look like, right? If it's a rectangular prism, it's all the faces are rectangles. Does it have to work out so that the cubes just fit perfectly? Well, no. We could have fraction of cubes also, right? And we don't want to do it this way, of course. This is just to represent what we're doing conceptually. We want to use a formula instead. And what is the formula for finding the volume of a rectangular prism? What must it be? Like in this case, if I know that this rectangular prism has dimensions of 5 by 3 by 4, just multiply them all together. Yeah, multiply them all together. Exactly. Okay. Now, our formula, let me skip through all this stuff. Our formula for calculating volume of a prism is just going to be multiply the base times the height. And that's what you just did, by the way. If we go back and look at, you told me to multiply all the dimensions together. That is what you did. You multiplied 5 by 3 to get the area of the base, right? And then multiplied the area of the base times the height. So without knowing it, you were following that very formula. Cavalieri's principle tells us that it doesn't even matter if the prism or the cylinder has been squished off kilter. As long as the base areas are all the same and the height is the same, the two prisms would have the same volume. So there's our formula for a prism. Volume equals base times height. For a cylinder, it's the very same thing, only this time we know what the area of the base is. It's a circle, right? So it's going to be pi r squared is the area of the base times the height. So there's our formula, pi r squared h. So let's just try one. If we want to, and you'll see this is much, much easier. If we want to find the volume of this right prism, what do we do? What kind of a prism is this?
What was the volume of the cylinder once again?
Oh yeah, volume of a cylinder. Here, we'll write it down. Volume of a cylinder is also base times height, but we don't write it that way because if it's a cylinder, we know that the bases are circles, right? And the area of a circle is just pi r squared. So we get pi r squared times h. Okay? Questions on that? Does that make sense?
Yep.
Okay. All right, so let's find the volume of this right prism. What kind of a prism is this? Okay, good. Right triangular prism, because the bases are right triangles. Everybody see that? And everybody understands that, right? This one's a little easier to see because it's sitting horizontally on the coffee table with the triangular surface down. But remember that when we're thinking about prisms, prisms are like non-circular tubes. So if this is like a triangular tube, isn't it? The bases are the parts that line up vertically, right? Another way of saying that is to create a prism, I'm going to take a shape and I'm just going to pull it vertically through space to carve out this tube. In this case, the shape is a triangle. So prisms are like non-circular tubes. Okay, so then if we want to find the volume, what was our formula for the volume of a prism? What was it?
Base times height.
Base times height. So what is the volume or the area of the base in this case, if it's a right triangle? Yeah, it's good. It's going to be 6. Good, because it's 1/2. We know that the area of a triangle is just half the base of the triangle times the height of the triangle, right? So in this case, let's go ahead and call 3 the base and 4 the height, or vice versa. It doesn't matter. So we get 1/2 times 3 times 4 equals 1/2 times 12 is 6. Okay. And the units would be, if we're measuring the lengths in centimeters, what would the units of the volume be? If we're surface area, it'd be square centimeters, right? But if it's a volume, what's it going to be? Cubic centimeters. Yeah. Okay. Make sense? So when you talk about, like in a car engine, when you talk about a 5.6 liter engine, liters are a measurement of what? Volume. Yeah, it's a different kind. It's a measure of liquid volume. It's how much liquid we can pour into something, but it means the same thing. A liter is just 1,000 cubic centimeters, is all it is. Okay. So we're measuring a volume, and what part of the engine are we measuring a volume of, incidentally? We're talking about a 5.6 liter engine. What's 5.6 liters? Yeah, the cylinders where the pistons go. And that's how much, when they're fully displaced, that's how much, the whole engine, that's how much displacement there is. It's 5.6 liters. Oops, did we ever finish this up? We got the I don't think we ever multiplied by the height, did we? We found the base. Base was 6, and then if we multiply by the height, we're going to get 2. Yeah.
The volume is 2.
So the volume is 12. 6 times 2 is 12, yeah. So 12 cubic centimeters. I think we forgot to do that, or I forgot to do that. Okay, what about the volume of the right cylinder? What about this guy? What's the formula for the volume of a cylinder?
Pi r h.
Pi r squared h. Good. So if we plug in the numbers, that's pi times, what's the radius?
8.
64.
Times height is 6. So that's going to be pi times 8 squared, which is 64, times 6 is some big number. Right? So what is that? 64 times 6, 128. So what is that? That's about 256 and 128. 64, 84, 384. Pi. Okay, and that'd be the best way to write it because that's an exact answer. They're probably going to make it a decimal, but that's going to make it an approximation. That's an exact answer. What would the units be in this case? For volume?
What? Oh, squared. Cube.
What cube this time? Inches cubed. Good. We're measuring the distances in inches. So we get 384 pi cubic inches. Let's see what they do with this. Okay, plug stuff in. Good. There's the area. So volume is area times 6. Oh, good. They left it that way. Excellent. 384 pi cubic inches. And then if you want to turn it into a decimal, that's roughly what it is. Okay. Okay, one last one. And then we'll finish up that video. Okay, so use the measurements given to solve for x. Now this time, what if we know we've got a cube with an area of 100 cubic feet? Okay, and we want to solve for the length of a side of the cube. What do? Yeah, we can plug what we know into our formula. Good. So we know that V equals S cubed, side length cubed. Or we know the volume is 100, so we just have to solve for x then. Now this is a little strange. This is one we're not used to. We'll come back and do a lot of this second half of Algebra 2, but we'll get a little glimpse of it now. How do we solve for x if x cubed equals 100? Do you know?
Don't you divide 100 by the cube root of x?
Okay. We don't divide. To undo a cube, we cube root it. Just like when we undo a square, we square root it, right? So we're going to take a cube root of both sides. But what does that look like? What's a cube root look like? Well, on your calculators, let me show you a couple examples of what you might see for that. Cube root, yeah. Strange animal, cube root. Cube root. Okay, here's how we do that. If we want to do a cube root, now there's a number of ways you can. Each calculator is going to be a little different. I'll show you on the TI-84. You actually can go to the math menu, and you can go down to the fourth item, which is cube root, if you want to. So there's cube root of what? Well, in our case, we're going to put in a 100. Oops, not 1,000. Okay, and if I hit enter, yeah, I get about 4.64. Okay. So you go to the math menu on the TI-84. Go to the math menu, and then the fourth option is cube root. Okay. Now a lot of calculators will have a cube root button. Either maybe you have to go second, or you might not be right on the front, but usually you can find that. So cube root of 100. Now another way of doing this, which will also work on the Windows calculator in particular, where I don't think they have a cube root. Maybe they do, but I don't think so. Is to take it to the 1/3 power. So I could take 100, and then I could just go caret, to the power of 1/3. Okay, if I take 100 to the 1/3 power, what do you know? I get the same answer back. Okay, so another way of doing that would be to take 100 and I could write 1/3 as a decimal, but what's the danger of that? Well, it's not perfect because it keeps repeating forever. So if I were going to do this, this is not recommended because of that. But if I did, if I hit caret, I've got to put in point. I want to put in a whole bunch of 3s. So it really does look like 1/3. And then if I hit enter, I get the same answer back. If I just put like a single 0.3 or even 0.33, it's going to be off a little bit, because that's not really what 1/3 is. So the easiest way would be this way. The best way would be either use the cube root, like the first way we did it, I think would be pretty good. Right, that way's fine. Went too far. Whoops, whoops. This thing has got such a lag, man. It's hard to tell. There we go. So the first one was fine. If you can find a cube root button, that's probably the best option. If you can't, whatever you're taking a cube root of, just raise it to the 1/3 power, and 1/3 is a fraction. That's just as good. Okay? Both of those are going to be exact answers. Questions on that? Okay. Okay, what about this one? I guess we have one more. What if we're given the volume of a cylinder? So in this case, it's 4,561 cubic meters. We know the height is 12, and we want to solve for the radius, x. Okay, start with the formula, right? We always start with the formula. Volume equals, and they didn't write it down. Let's us do that. So the formula we want is pi r squared h. Right, we'll plug in all the stuff that we know. Okay, now we know that the volume is 4,561. We know that the height is 12, and we call the radius x. Right, so we'll just simplify that thing and isolate x. Pi times x squared times 12 is the same thing as 12 times pi times x squared. We want to put the numbers first, then the symbols, and then finally the variables. And then to isolate x here, if I can point to a single x, I can isolate it. What do I do to get that x by itself first? To know, I can just reverse order of operations when I want to isolate or solve. Go bottom up. So first we need to add or subtract. Well, there's none of that to do. Multiply or divide? Yep. Divide by 12 pi. Good. Divide both sides by 12 pi. And then that's going to cancel out the 12 pi from the right side. Okay. That's good. So that step's done. Then we go on to exponents. Aha, there is an exponent. We have to undo that too. How do we undo a square? Square root. So we'll just square root both sides. If I square root that whole fraction, evidently I get about 11 if I round it. Okay? So x is roughly 11, approximately 11. Okay? All right. Make sense? Don't you agree? You haven't done this yet, probably, a lot of you, but doesn't it seem a lot easier than the surface area stuff? It's a lot easier. It really is. So if you can do the surface stuff, you got it made. That's the hardest stuff in the chapter by far. Oh, one more. I forgot about that. This is a good one. I forgot about this one. This is a really good one. Well, we'll just go through this quickly here. But I like this one because the shape is so strange. Yes. Yeah. We're trying to find the... we know that concrete weighs 145 pounds per cubic foot. That's the density of concrete. To find the weight of the concrete block shown, you need to find its volume. So if we knew its volume, we could just multiply by 145 pounds per cubic foot, and we'd get the weight. Okay? How do we do that, though? Look at this concrete block. Like, concrete, these cinder blocks like this, they've got the two square holes that go all the way through to reduce the weight. Okay? So if I wanted to find the volume of this thing, I've got to find the cross-sectional area of it times the height. How can I find the area of just the concrete part if it's got these two holes all the way through, from base to base? I could find the area of the whole big rectangle and subtract away from that the areas of the holes, right? And that's going to give me the area of just the concrete part. Make sense? So the cross-sectional area of the whole thing would just be 1.31 length times the width, 0.66. Okay, and that's, right, there's the whole volume, or the whole cross-sectional area. To subtract away the holes, each hole has dimensions 0.33 times 0.39, and there are 2 of them. So then doesn't this work for us? There's the area of the whole cross-section, including the holes, minus 2 times 2 times the area of one of the holes. I kind of did that like this.
What's that?
Right, so we're just getting area for now. Just calculating the area. We haven't gotten to the height part yet. So minus 2 times the area of a single hole. That gives us, and here's something I don't like, but sometimes the book does this. Then they turn that into a decimal. Good idea? No, bad idea, because they're gonna propagate error. They're gonna accumulate rounding error. We'd rather not. We'd rather keep this in our calculator as one huge decimal that we can go up and grab, okay, or do it all in one calculation. But if we round, we get about 0.61 square feet. Then is the area of just the concrete part of the block. So then all I have to do to get the volume of concrete is multiply by the height, 0.66, right? So if I take 0.61 times 0.66, I get about 0.40, and then that would be cubic units, cubic feet. So if I have 0.40 cubic feet, if I multiply that by the density of concrete, 145 pounds per cubic foot, I get about, 40% of 145 is about 58 pounds. So that's a pretty big block, 58 pounds. Yeah, that's heavy. Okay, make sense? Yes? Yeah, go ahead. Okay, good job. Let's finish up our